Alright, for example 2, all we have to do is to multiply these guys. So since they're both binomials, we're going to use the box. You guys know the box. He's your favorite. Okay, we have radical 3, radical 2, and then radical 3 plus radical 2. And then we start multiplying stuff. So if we go radical 3 times radical 3, we get radical 9, and that will simplify. Radical 3 times radical 2, we get radical 6. That one will not simplify. Radical 2 times radical 3 is radical 6. And then we have radical 2 times radical 2. That will simplify. Normally when you multiply the you multiply like radicals, then it will simplify when you go to simplify it. So let's see, this one's going to be a 3 because the square root of 9 is 3. When I add these guys together, you gotta imagine that there's a 1 right here and a 1 right here. So we have 1 radical 6 there and 1 radical 6 right there. When I add those 2 radical 6's together, we get 2 radical 6's. Okay, notice I'm only adding the 1's. We're not adding the 6's together. The 6's are inside of the radicals. You can't do anything with them when they're inside. Treat the radical 6's like they're x's. So it's kind of like 1x plus 1x, which is 2x. Alright, then the radical 4 simplifies to 2. When we write this out, we get 3 plus 2 radical 6 plus 2. And I can add these together because those are like terms. Those are both integers without radicals. So we have 5 plus 2 rad 6. And that's what we get when we multiply the first ones together. Now let's multiply the second ones together. For the second ones we have, let's see, how does it look different? We have a radical 3, radical 2, kind of the same, radical 3, and then a negative radical 2. Oh, this should look familiar to you guys. You guys remember doing things like a plus b times a minus b? You guys remember that? That equals a squared minus b squared. That is a difference of squares because we have a and b, and one's plus, one's minus. Okay, so we have a right there. There's our A. We have a B right there, B right there. The B is the one that's opposite signs. And let's see what happens. Let's see what we get. So we go rad 3 times rad 3, and that gives us rad 9. Same as last time. Rad 3 times negative rad 2, that's going to give us negative rad 6. Then we have rad 2 times rad 3, that gives us positive rad 6, and then rad 2 times negative rad 2, that's going to be negative rad 4. So we go to simplify this jazz, we get 3, because square root of 9 is 3, and then these guys, when we add these guys together, this time we have a negative 1 and a positive 1. Those cancel each other out. That's right. So we have 0 rad 6's, you don't even have to write it, since it's 0. And over here we have a negative square root of 4, so that's going to be dose. And so we're left with 3 minus 2, which equals 1. Ooh. Okay, so right here it talks about, then explain what you noticed about the 2 different results. You can pause it right here and see if anybody wants to offer some stuff here, some explanations. And then press play when you're done. Okay, you guys should have said something about this one still having a radical and this one not having a radical. That's something that you need to notice. When you multiply 2 binomials that appear to be like a difference of squares, then we're going to not have a radical anymore, which is kind of cool. So go ahead and practice that with your next exercises. They look like these guys. Okay. Oh, and so these are called the conjugates. So this and this are conjugates of each other. When you multiply conjugates, the radicals go away. Yay!